here we go. First off, homework is due on Monday from chapters 9 and 10. Anything for homework questions for chapters 9 and 10? Anything there? Homework questions, chapters 9 and 10. People are shaking their heads at me. No homework questions from chapters 9 and 10. We're good? Everybody good? Okay, all right. That's the first thing. Second thing, we are starting chapter 12 today. So I'm looking at my schedule. Hang on, sorry. So much easier to do this in the front of the classroom when everything's on the desk and I don't have to leave the screen. Okay, chapter 12 is gonna be today through next week, Friday, 4 days worth, 4 class periods on chapter 12. So that means we've got 3 homework assignments left. The one due on Monday from chapters 9 and 10, one due on chapter 12, and then the stuff on chapter 13. So that's where we're finishing up. All right. Test number 3, remember that test number 3 is during the final exam period. So that is Monday, May 11th, I do believe. Monday, May 11th at 8. It is just a regular test. It is not an exam. So I'm going to write it to take the same amount of time as a regular test. But that means we can start at 8 instead of starting earlier because it won't take the whole hour and 45 minutes unless you're very, very slow, which I don't think you are. So there's that. Proof notebook is due the last day of class, Friday, May 8th. I believe I set up a spot on Moodle to turn in the proof notebook. But again, if you want to turn it in some alternative way, that's fine. You can do that. Anything else for housekeeping questions before we get into chapter 12? Anybody, anything? Okay. We lost Lauren's video. Maybe she'll come back. All right, chapter 12, whiteboard. Here we go. Oh, there you are. She moved. Okay. All right, chapter 12, section 12.1. We're going to see how this goes. Usually I teach chapter 11 before I teach chapter 12, and I decided that chapter 11 was kind of the other stuff that we were gonna skip this semester. I looked at my notes because we had that extra week of spring break. I looked at my notes. I think we're gonna be okay, but if not, if there's things that I say that you don't have the frame of reference for, make sure to ask either in the chat or live, either way. I am pretty good at catching it in the moment, but just as a heads up, my notes are written, especially if you look at my notes on Moodle, assuming that we've done chapter 11. So just be aware of that as we're going through. All right, section 12.1 is functions. Today is going to be very few proofs, a lot of definitions, and then looking at 3 different ways to create a function. So let's do a definition first. This is the one that's going to serve us all the way through chapter 12 and for lots of math classes beyond this. So here's my definition. A function. Usually we use the letters F from a set A to a set B is a subset of A cross B where the following 2 properties hold. This is not how you're used to thinking about a function, and that's okay. We'll bring it back to the way that you're used to thinking about a function in a couple of minutes. But for right now, we're thinking of a function as a subset of A cross B. And remember what cross product is, right? That's ordered pairs. They go in parentheses. First element is from capital A, second element is from capital B. So 2 things have to happen. First of all, for all little a living in capital A, there exists some little b living in capital B so that A comma B lives in F. I don't think you like this notation, and I'm okay with that. I'm not sure that you're wild about A comma B living in F. That's a little bit disconcerting. But go back to what we had up here, right? A function is a subset of A cross B. A subset is a collection of a bunch of ordered pairs in this case. So we can say that an ordered pair lives in the function. This is not the notation that you're used to. You're probably a little uncomfortable with it. That's okay. Second thing for a function is if A comma B1 lives in F and A comma B2 lives in F, then B1 is equal to B2. So if two ordered pairs with the same first element, little a, live in F, then their second elements have to be the same as well. This is the idea, which you've probably heard, that a function passes the vertical line test. So this is the idea of a function passing the vertical line test. Give me a thumbs up, tell me you've heard of the vertical line test before. Yes, okay, that's what this one is saying. Let's talk notation, because this is how you're going to be used to seeing functions. So here's the notation. This is the notation that I use. I'm not sure if the book uses this exact same notation or not. So I do little f from A to B. So that's the set that is the first half of the ordered pairs and the set that's the second half of the ordered pairs. And then I say that little a goes to little b and I put a head on the arrow. So the first line of function notation, my function notation, is the sets. The second line of function notation is the elements themselves, and that's with an arrow with a head on it. I'm pretty sure that in LaTeX, this is maps to, but you can use detechify, you can draw it in and make sure that you get the correct symbol there. I think that it is maps to, but don't quote me on that one. Okay, and so what this is also going to be for notation, and here's the notation that you're more comfortable with. So if an ordered pair A comma B lives in the function, then here's the way that we usually write it. F of A equals B. It took me 8 minutes and I got to notation that you like. Here's the notation that you like. So F of A equaling B is the same thing as saying the ordered pair A comma B lives in the function. That's the notation that you're more comfortable with. So in other words, a lot of times we will say an ordered pair is A comma F of A. That's another way of saying it. Okay, let's get a little more terminology and then we'll talk about different ways of defining functions. So more function terminology, here we go. So function terminology. A little bit of this is what you read about, but I'd still like to write it down. So once again, we are going to say that F goes from A to B. It sends an element little a to an element little b. First of all, capital A is the domain of the function f. So capital A is the domain as the function f. This is the set of all possible inputs. So domain goes with inputs. Domain is the set of all possible inputs. That's what my domain is going to be, capital A. Secondly, capital B is the codomain of little f, codomain. The codomain is the set of all possible outputs. That's the codomain. So the domain is the set of all possible inputs. The codomain is the set of all possible outputs. And then we've got this thing called the range, and this is where things get a little confusing. So the set, little f of A, so that A lives in capital A is the range of little f. The set of all f of A, so that A lives in capital A, is the range of f. And this is the set of all actual outputs. So we've got a codomain and we've got a range. They are related. The codomain is all possible outputs. Anything you could possibly get this big set as an output for the function. The range is all the outputs that you actually get. So that's the difference between these two. Codomain is usually very, very easy to find because the codomain shows up immediately in your definition of the function. No big deal. Range is harder to find because you have to say what outputs do I actually get as opposed to what are all of my possible outputs, okay? So that's the difference between the codomain and the range. We'll do some examples. Any questions at this point before I talk about how we can define functions? There are 3 different ways to do this. Anything for questions at this point? It's still all pretty abstract. Anybody, anything? Okay, let's talk then about 3 different ways to define functions. So, ways to define functions. I'm sure there are more than 3, but these are kind of the most common ones that come up. First is to list all the ordered pairs in F. That's the first way you can do this. You can list all the ordered pairs in F. So once again, remember, definition of a function is that the function is a set of ordered pairs. So you could list all of those ordered pairs. We're going to do one with this. We're going to come up with the domain. We're going to come up with the codomain. We're going to come up with the range. Second thing you could do is what's called an arrow diagram. So we can create an arrow diagram for F. So create an arrow diagram for F. That's the second way that we could do this. Pictures are fun. We'll do one of these too, create an arrow diagram for F. And then the third one is define F using a rule. This is probably the one you're most familiar with. Define F using a rule. First 2 are going to work for small domains, codomains, but they're not practical to scale because you're not going to want to list all the ordered pairs if you have like 50 ordered pairs. Or if you have an infinite number of ordered pairs, there's no possible way to do the first one. Same idea for the second one. An arrow diagram works for small domains and codomains, but not if you get any bigger. So the third one, define F using a rule, is really the way that we need to do any sort of generalized functions. The catch with this is that for these first 2, it's easy to find domain, codomain, and range. That's easy. Those are easy if you do an arrow diagram or if you list all the ordered pairs. But these are hard if F has lots of inputs. So that's the trade-off. It's easy to find domain, codomain, range, but if you have a lot of ordered pairs in F, this is not going to work well. For defining F using a rule, this is easy no matter how many ordered pairs F has. So no matter how many inputs or ordered pairs either way F has. Easy no matter how many inputs F has. This is super easy, but it's harder to find range especially. Harder to find range especially on this one. We're also going to talk about some properties of a function in 12.2, injective, surjective, bijective. That's something else we're going to talk about. Injective, surjective, bijective, once again, are easy to find if you list all the ordered pairs or do an arrow diagram. It's harder to figure out injective, surjective, bijective if you define F using a rule. But if F goes from the integers to the integers, there's no way you can list out all the ordered pairs that way. So that's the trade-off. Easy to analyze, hard to do if we have bigger functions. Okay, anything